All right. I have a study guide that I've given you guys. Is that right? For a little test that's going to happen Wednesday. Say again. Emailed it last week-ish sometime. I could email it again if need be. Yeah. Okay.
Just look up his name in your email and it'll pop up as the last email that you got.
Okay, even better. That'll work. Okay. GM, so today is review day according to the calendar here. So we got 4.1 all the way to 4.7, all the good stuff there. There's some calculator questions. There's some honors questions right there. Hopefully, I don't know, raise your hand if you took the time to look at the study guide prior to coming to class today-ish. Okay.
I clicked on it.
Clicked on it. Okay, there's that something. Okay. Sounds good.
It is in my history.
Okay. Okay. Let's jam with this one then. Here, let's see. So just to make sure we're on the same page, so review today and homework questions. If you guys have any, we'll do that, and then I'll maybe throw some questions at you guys here. Exam 4 is Wednesday. Have fun. And then there's no physical school on Friday. I think you guys know what to do. And then, yeah. So we come back to final review, which I'll send you guys. I'll probably give it to you guys Wednesday, the final review study guide sort of thing. Okay, we'll come back to it, look at it on the 8th, and then take a final there. Okay, we're good there. Let's jam with homework questions. Let's jump to this.
So if we don't get to some homework questions, what should we do?
Say again, say again.
Like if we don't get to some homework questions, what do you want us?
Like don't get to 4.7 sort of thing?
No, like
We usually take multiple days. Like,
yeah. So
Gotcha,
that's
yeah.
what multiple review days.
And also, this one has 2 more.
Yeah.
I mean,
And the last thing is pretty.
So it's just, I just feel like it's likely that we won't.
Yeah, gotcha. Okay, so let's start. Let's do as much as we can. How about that?
Okay.
And then we'll go for it. Time remaining. Okay, give me section and problem. How about that? Almost there, almost there. Say again.
25 and 37.
Which section? 4.1, 25, 37?
Also in 4.1, 39.
Sorry?
Also in 4.1,
39, okay. So just give me section first and then give me the numbers afterwards.
And okay.
4.2, 17.
17,
4.351.
Yeah.
4.3, 33, and 49.
33, 49?
Yes.
4.5, 31, and 35.
457.
This is kind of jumping ahead, but for 4.7, I don't think we fully went over kind of the last concept of figuring out like,
We didn't do tangent, we didn't do some other ones.
yeah, like when you have like tan multiplied by the tan to the -1 of the 1/2. I think Fred and I were reviewing it, kind of figured it out, but it'd be nice to go over it.
Thank you so much. That's right, yeah. There was a few things I kind of left out there.
In 4.7, 45 and 81.
Okay, there's our list.
Oh wait, not 45, just 80.
Doo-doo. Okay, any others? Oh, it's going twice. Okay. Let's begin. Let's go for it here. Let's see how much we can do here. So 4.1, number 25. We are going to look at the unit circle and the fact that cosine is an even function and find this right here. What is cosine of -60? I'm gonna go kind of fast. You guys slow me down if you need to, okay? So cosine is even function. It goes like this. That's cosine. So whatever happens on the positive x-axis is the same thing that happens on the negative x-axis. So what you do with cosine, because it's even, we get to drop the negative sign that's inside here. So cosine of positive 60 will be the exact same thing as cosine negative 60. It don't matter. You can always drop the negative signs with cosine. You can always drop the negative signs with secant. Those are the only two that are even functions. The other ones are odd functions. So if I were to say sine of negative 60, that one means you'd have to put the negative in front. That is what an odd function does for a trig function. Are we good? Cool. So cosine of 60, then I go back to my unit circle. It's like this somehow, is that right? So this would be 1/2 comma root 3 over 2. And I think it'll be 1/2. Tell me if you guys agree or disagree.
That's what I got, but it didn't make sense.
Okay. Now does it make sense with the even and odd kind of stuff? Maybe.
I don't understand like how degrees relates.
Talk to me about.
On your unit circle, you can just look at your textbook. You know how there's like the certain angles and then cosines is the first one instead of planes.
So on the unit circle, you are going to look over here on your back cover of your textbook, and just the connection between and then the unit circle. So you're going to look for the x coordinate to be 60 degrees,
So it's
right?
just finding the coordinate.
Yeah,
That
Because-
makes sense.
Because with cosine and sine on the unit circle, cosine is your x coordinate and sine is your y coordinate. Okay, we're good there. Awesome. 37, 39, same section. Show that tangent is an odd function. How do you do that? So we've looked at the fact that sine and cosine, you kind of build it off of sine and cosine. What is the relationship of tangent, sine, and cosine? Arno? Sine and cosine, perfect. So I'm going to prove it. Here's my proof here. So tangent of negative theta, I'm going to switch that up to be same thing as sine of negative theta over cosine negative theta.
Wait, why did you use negative?
We're trying to prove that tangent is an odd function. And so what I need to prove is I need to prove the fact that when I take tangent of negative theta, I'm going to have a negative outside in order to have a positive. I'm going to prove that. That's what being an odd function is. Okay, good there.
Just to remind you, this is recording, right? It's published.
It is. Hopefully it is. It's recording. So this one here, we know on top, sine is an odd function already, right? So then on top, it's going to be a negative sine theta. On the bottom, cosine's an even function. We can drop the theta, the negative itself out, and voila, look at that. I have a negative sitting in front of a sine over cosine, which just makes, voila, I just proved it, just based upon what I know for sine and cosine. Okay. I think I can probably put 39 right underneath here. First, thank you guys for all the homework questions. That's a good thing. All right, then we got identities. Remember those guys? You had to stay on one side of the equal sign, and then you had to simplify and see if these two sides match each other up. This was prove that, or prove each identity. I think this is when we did like this right here. Put a little bar line down, and then we said to ourselves, okay, let's start simplifying the sides. The right side is pretty simplified. Then you can do there. How about sine? Sine, oh, let's do this. Let's get rid of all the negative cosine, negative thetas here. So sine, again, is an odd function. Everybody okay with this guy? Cotangent, even or odd? Cotangent. Gonna go. It's odd, right? Because the only even functions are sine and sorry, the only even functions are cosine and secant. That's it. Just those little pairs. So I'm gonna go with a negative cotangent theta. Negative times a negative is a positive. And now I can just make everything into sines and cosines as much as possible. And so sine stays exactly the same. Cotangent becomes cosine over sine. And I think the sines can cancel themselves out now. And voila. I have proved that. And anybody know the little Latin acronym that was said that we have just proved something? Awesome. I'll go with that. Boom. Prove those are exactly the same. Okay, we're good there. 39. Speeding, just hopefully not too fast. 4.217. Graph one complete cycle each of the following. In this case, label the axes accurately, identify the period for each graph. Let's go with it here. 4.217. We need to graph this guy. And hopefully, as you guys went back to the homework, these easier ones were like, oh, that's so easy now. Especially 4.2 when we're just getting into graphing here. So first, let's see, the two things that we talk about, or the three things we talk about is amplitude. And amplitude is the number in front that's a multiplier. So in this case, it's just 1, right? It's not increasing or decreasing it. Next thing we talk about is period. Now the period value is b divided by, 2 pi divided by b. And the b value is this little guy right there. So a little bit of work just because we have complex fractions here. I think I got that on my hands. Changing it to a multiplication problem. I think it's 2 pi over 1 multiplied by the reciprocal of this guy. Boom, pi's are gone. And it looks like I have a period of 4. That's nice. So the b value, if it has a pi inside it, all happens is we just got rid of pi's for our x-axis, or yeah, x-axis. Okay, and then we talk about reflection. Is there a reflection? And we ask ourselves is, do we have a negative a value? That's the question. And no. Okay, so one complete cycle would do this. This would be 1, 1, 1, 2, 3, 4. There's my 4. There's my 1. And the sine function does this right here. Starts off at 0, 0 originally and goes up to 2 pi as a single period. In this case, it's going to start off at 0, 0, go up to 1, down to 0, down to -1, up to 0. By the time it gets to 4, that's what a period means. Boom. We're good there. Shucks. That middle term, I didn't hit the dot. Ah, that's cool. Now we did. We're good now. Okay, 17 good. And we can label this -1, I guess. Boom. This is totally fun. 4.3. Sorry. Ding, ding. 33, 49, 51. All right, 33. Let's do that and then we'll see if we can, I'll maybe do something. Let's see. 4.3, 33. We are to graph. All right. 3. Now it's getting fun here. So identify amplitude, period, phase shift, label the axes accordingly, sketch one complete cycle. That's cool. So amplitude is 3 right over here. Again, that A value. Period is going to be 2 pi divided by B. Again, that little guy right there. There's my B value. And if I do that, that becomes 2 pi divided by pi over 3. And this is going to be 2 pi over 1 multiplied by 3 over pi. Are we good there? That was just the last one that we just did. Pi's are gone. And it looks like I have a period of 6. Reflection. That's a no, because 3 is positive, no reflection. And then that's the one that we usually make first. And then we have this one here. We have the phase shift now. Phase shift is a negative C over B. And this guy is the C value right here. So in this case, it's a negative of a negative pi over 3 over pi over 3. And voila, that's fun. Negative times a negative is a positive. And if you got the same number divided by the exact same number, it's just going to become a 1. So now I think I got what I need here. Let's see, I'm going to go all the way out to 6. 1, 2, 3. That's what I have here. 1, 2, 3. And that's 6. That means that's 3 here. 2, 1, 4, 5. Okay. And what we normally do is we just graph this first, because it's easy to graph the amplitude because you're just extending it up and down. It's easy to graph the period because you already know what the period is. And so we do this by dots. So let's see, half of that would be a 3, and half of 3 would be about 1.5. So that's a little tick mark that I need to know. This guy's at 4.5. That's another tick mark I need to know because I've divided it into 1.4 units each. We're good. And so this is sine, starts off at 0, 0. It's going to go all the way up to 3 when it hits here. It's going to go down to 0 when it hits here. At 4.5, it's going to go all the way to -3, and then up to 6, or up to 0 by the time it gets to 6. So I'm going to do this first. A dash line. And if you can graph it all at once, that's cool too. I just want to at least do this one right here.
Wait, can you explain again why it's at 1.5 and 4.5?
For the sine function, it's always 2 pi is a normal process. And notice we divide it up into 4 different parts right here. So we take half of this guy, take another half, and then we technically would do is we multiply these, add these guys together to give us that little third piece. So it's always divided up into 4 pieces each time. And so if we take 6, 6 divided by 3 would be 3, and then that would be 1.5. Cool. All right, and now we have a phase shift. Now we do the phase shift. I think I barely got it in here. Phase shift means we're going to move everything over 1 to the right. So that whole entire dotted line gets shifted over. So now we start off at 1. It's actually always easy to use the zeros first. So 3 now becomes a at 4, and the 0 at 6 now becomes a 0 at 7. So instead of 1.5 being the maximum value, now we have a maximum value at 2.5. So again, this just shifted 1 unit over. 4.5 just shifted over to 5.5, 1 unit over. And from here, we can graph it now. That's when we put in the solid line here. Boom. There's my one single cycle here. Okay, everybody good there? I know I'm kind of talking a little bit quickly here, but is that okay?
Wait, so it's at 2.5, not 2?
Should be, yeah, because at 1.5 is the max, so we shifted over 1 unit. Cool. All right. 49. All right. I like to write 49 a little differently. I like to write the trig function first. Then write that little 5/2 or the extra number in the back. It just kind of sets everything up because that's my A value. That little pi guy is my B value. This is my C value, and there's my D value. And D is going to be my vertical shifts up and down. So again, the same process applies here. Amplitude goes first. Amplitude is just the absolute value of the A value. If we want to put things in here, it's just going to be that guy. That's the 3. That means from the middle of this graph, it's going to go up 3 and down 3, up 3, down 3. Right? Period. 2 pi divided by the B value. 2 pi divided by pi. Voila, love it. That is a period of 2. And then do we have ourselves a reflection? Okay, so based upon that right there, we should be able to graph our first graph. Yay. I'm trying to listen in on trigonometry. Okay, boom, boom, boom. Let's see, we can set the other stuff up here. So PS for phase shift, it's going to be negative C over B. So how about a negative pi over 4, negative of a negative pi over 4 divided by pi. Negatives are gone. Change this guy into a multiplication problem. This guy stays the same. This guy gets taken the reciprocal. Pi's are gone, and are we okay with 1/4? So we have a scooting of 1/4 of everything that we just did like the last problem to the right. And we have the vertical shift, phase shift and vertical shift. Vertical shift is just D. So we're going to go up 2.5 on this guy. All right, so let's do this real quick here. This is kind of helps when you're trying to set up your X and Y grids. If you go back up here, you know that cosine and all this right here, the highest this could ever go is 1. And the lowest this could ever go is -1. We're good? Because we're going to just take cosine. And so what we do is we just say to ourselves, okay, if cosine reaches its maximum for this value here, it's going to be -3 multiplied by 1 plus 2.5. And I'm just making that 5/2 into 2.5. Are we okay with that being a -0.5? And then we'll go the other way. -3 times -1, because that's the lowest of cosine goes, adding 2.5. That's -3. No, that's +3 now, right? +3. And 5.5. Are we good? So as far as the Y value goes, here's your minimum Y value. Here's your maximum Y value. All right. Okay. And my phone woke up. All right. Okay. Let's go with it. Are we good? Ready now? So let's go back over here, graphing these guys. So I'm looking at a cosine curve. Cosine curves go like this. But I'm also looking at a reflection. So I'm kind of starting off already thinking about something that looks like this. Starts low, goes up, and makes a little mountain now. And originally, it goes to 2 pi. Now it's going to go to 2 only. So that means half of that would be at 1. Half of 1 would be at 1/2. So 1/2, 1, this will be a 3/2 or 1.5. Makes 2. Okay, we're good there. And then we're gonna go up 1, 2, 3, 1, 2, 3. Notice I can sort of sketch that little graph very easily. So my first graph, I'm gonna lose space here. And I'm gonna go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, because eventually I want to get 5.5 in here somewhere. This is going to stretch out to 1, you know what, my x-axis, is that okay? I'm going to make it into, this goes up by 1s. I'm going to stretch out my x-axis a little bit here like this, just so I can see the up and down motion. So this is going to be 1/2 right here. This will be 3/2 right here. So 1, 2, 3, -1, -2, -3. So let me graph my original graph like this one right here, in terms of dots. So it goes like this. It goes up all the way to 3. When it reaches 1, comes back down and reaches the low point at 2. Everybody okay with that one? Everybody okay with that graph and why I graphed it? Okay, so now we're going to include this one. We're going to move it a quarter to the right, and we're going to move this guy 2.5 up. So if you want to move these individual dots, because that's what's going to happen, it's going to move over a quarter of a unit. That's half a unit, and it's going to move 1, 2.5 up. So this little dot here just went to that little dot right there. And so we're just moving it based upon these guys right here. Each dot, what we call each critical point, we're going to move quarter to the right, bless you, and 1, 2.5 up. This little maximum value now. So that was the 0 right here. That went up. That little maximum value 1 now switches to 1.25, and then 1, 2.25 up, or 1.5 up. 3/2 moves over a little bit here, and then 1, 2.5 up, and then this guy, the last one here. So 2 - 3 goes to 2.5. Sorry, 2.25, and 1, 2.5 up right there. So how about this guy as the graph? Looks something like that, where the end value is 2.25. I'm debating, I'm going to do 51 then. Okay, here we go to 49. On the homework questions that we don't finish, I think what I'll do is I'll have to do a video today, as soon as I get home, sort of thing, and just post it, just so you guys can finish up the homework. And then I'll post a little section on 4.7 that we didn't finish, maybe more detailed. And I'll probably make it a little really detailed, so a whole bunch of example problems if you need it. So let's do 51 together as an application problem here. I have a spring and a weight on a spring. It's right here. And then it goes like this, because this guy pulled it down to this little lever right here, and just gonna let it go. So mass attached to the spring oscillates upward and downward and given by this function. L is equal to I don't like the way it's written like that. I normally like to see it like this. That's a lot. Kind of in my mind, that's easier to sort of think things through. Oh, and T, sorry, I'm forgetting T here. So 2 pi T. Sketch the graph on the function from 0 to 5, cool. What is the length of the spring when it's at equilibrium? Find the length of the spring. And so let's do a few things here. First is, and so the length of the spring from here to here, that's L. Okay, and we have 5 minutes to do it in. What's the length shortest when it's longest? Okay, let's go with it here. We're going to sketch this little graph right here. In fact, 49, we did something very, very similar. Is that right? So let's do that here. Amplitude is going to be 3.5. Are we good? Period is going to be 2 pi divided by 2 pi. Are we good there? It's the little multiplier to your variable, which is t, 1. And then the question is, do we have a reflection? And it's a yes, because a little negative right there. We're good? So cosine curve, again, memorized in your brain. It's etched in your brain. Cosine curve is normally like this. And because of the changes right here, now we have a period of 1. So break that up into units. That's going to be 1/4, right? 1/2, and then half breaks down into 1/4. 3.5, so it goes up and down 3.5 now instead of just 1. And it's upside down. So if we start down at 3.5, crosses over at 1/4, goes up to 3.5, comes back down, and then goes down to 3.5. And we'll sketch that graph in just a second, but that's such an important point. If you guys can kind of do that in your mind and sketch it really quick here, you know just those 3 different changes. All right, phase shift is 0. There's nothing that's being added. There's nothing there. It doesn't say 2 pi t plus pi over 2 or anything else. Vertical shift, yes, vertical shift, it's a 15. So really the only thing is we're going to take this graph and move it up by 15 units. And so at this point, I think we can do that. So I'm going to go all the way down here, have it like this. This be a 1 for me. That's a 1/2. That's a 1/4. 3/4. And this guy gets shifted up 15 units. So instead of it being at a -3.5, what do you guys say? What's -3.5 plus 15?
Wait, -3.5 or +15?
-3.5 plus 15.
11.5?
11.5, okay. And then the positive 3.5 plus 15. I'm gonna go 18.5, is that right? Cool, okay. So, whew. Maybe this guy will go further up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There it is. So I start off at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.5. At 1/4, it's going to go to 15 here. So that's 11.5. That's 12, 13, 14, 15 is right here. At 1/2, it should stretch out to 16, 17, 18.5. At 3/4, back to 15. And at 1, we're down to 11. Okay, are we good there? All right, with 3 minutes left, let's answer the questions here. That's the sketch, that's A. B. What is the length of the spring when it is in equilibrium? And so what the book is really trying to say is because a spring retracts, right, and comes back. So if you go up and down like this, the middle point is really just going to be this little piece right here. So at rest, if it eventually stops bouncing around, right, it's going to stop and start resting here. It's going to be 15, what is this, 15 inches, 15 centimeters. C, what's the length of the spring when it's the shortest? Shortest would be, we got it already, 11.5 centimeters. And then when is it the longest? 18.5, because we've modeled that behavior by the sketch of the graph itself. Good. It's kind of funny because if we were thinking about pulling this down, right, it was at equilibrium here. We pulled it down to here, right? And so visually, the graph is starts low, right? And so we've got a visual representation of the graph as this guy moves up and down. We have visual representation. Okay, we're gonna have to stop anyways here. So class, I do have to get through the rest of the homework here that we didn't get through here. And so we're here. So 4.4 and on, I got these 3 homework assignments. And what I wanna do is an 81, is that right, Brenna?
Mm-hmm.
Okay. Okay, and I will make a detailed 4.7 lecture. If you want to finish listening to that, and we'll go from there. And I'll post it by 8 o'clock or so. Same time. Anyways, thank you so much. You guys have a great day. And if you do run into any other issues here,